In this lesson, we will learn how to use this formula, and also we will use that to show you how a calorimeter works and also a bomb calorimeter. Okay, so let's begin by looking at example number 1. In this example, you have a Cheeto that's burning, and you, just like in your lab, you have a 50-gram sample of water. So in your little cup is 50 grams of water. And you're burning the Cheeto here. You put a thermometer in there, and I'm going to draw it here because you can't see. The thermometer went from 22 degrees Celsius, it says a 50-gram sample of water is heated from 22 degrees Celsius to 75 degrees Celsius. When the Cheeto is burned, calculate the amount of heat released in the Cheeto. So the symbol for heat is Q. If you want to know the heat, then you have to know the specific heat capacity of water, because the energy went, or the heat went into the water. Water takes 4.184 joules to heat up for every gram of water that you have for every degree Celsius of increase. Okay? If you heated 50 grams of water, then you have to multiply this by 50.0 grams. If you made the temperature rise from 22 degrees to 75 degrees, you see the difference, which is 353 degrees Celsius. Okay, when you multiply this, the grams cancel, the Celsius cancel, and you're going to end up with the joules. So here the joules is about 11,088 joules. With sig figs, it's about 11,100. Okay, so you can see that this is the formula, the same formula as above, okay, where this is the specific heat of water. This is the heat. This is the mass. This is the mass of the water. And this is the change in temperature of the water. The reason I'm writing water here is because these are all for water. The heat that you get is going into the water. Okay? So the heat that you get went into the water. So the heat that went into the water, which is positive 11,088 joules, is equal to the heat that left the Cheeto, which is the same amount but negative because it left the Cheeto. Okay? By trapping the heat into the water, we're able to measure the heat that left the Cheeto right here. So when they ask you the question, calculate the amount of heat released by the Cheeto, it's negative 11,088 joules. So this is obviously exothermic. So burning a Cheeto is exothermic, and it went into the water. Also, this is also delta H because there's no work done. Delta H is the same as Q. So delta H is also negative 11,088 joules. Okay? This is a chemical reaction, so sometimes I write RXN down here, which means this is the delta H of a chemical reaction. That is RXN. Okay, now it's your turn. Go ahead and do example number 2. Okay, so now let's do example number 2. When the solid is dissolved in 60.0 grams of water, the temperature went from 22 degrees to 10 degrees Celsius. Calculate the amount of heat transferred. The formula is Cm delta T is equal to Q. Q is the heat that's transferred. So this is going into the water, so we're going to use water again. 4.184 J over GC is the specific heat of water. The mass of water is 60.0 grams. The change in temperature, so the change in temperature here is delta T is equal to T final minus T initial. Okay, The final temperature is 10 degrees. That's what you end up with, 10.0 degrees Celsius. The initial is 22.0 degrees Celsius, negative 22.0 degrees Celsius. So 10 minus 22 would make negative 12 degrees Celsius. Negative 12.0 degrees Celsius. So this is a negative 12.0 degrees Celsius, which means Q would be equal to, when you multiply that out, the grams cancel, the degrees C will cancel, and you're going to get negative 3012 joules. Okay, let's go ahead and analyze that. This is Q, which went into the water. The water is the surroundings. So whenever we're doing this, we're measuring the surroundings, because we can't really measure the chemicals itself. So water is a part of the surroundings, equals negative 3012 joules, which means Q of the system is opposite that, because the water lost heat, so the heat went into the system, 3012 joules. Okay, so the amount of heat transferred is this. We're looking at the system, but we're measuring the surroundings. Okay, so it would be this. This is also called delta H, because there's no work, is equal to positive 3012 joules. Because this is when you're dissolving something, a dissolution reaction, this is dissolution. I can write reaction for Rxn. If I want to be more specific, I can also write, this can also be the same as delta H of solution, SOLN. Okay, the same with this. This can be delta H of the chemical reaction. If I want to be more specific, it is the delta H of combustion, because I am burning the Cheeto. So the subscript here just gives you a little bit more information of what's happening. This is the heat when you're burning a Cheeto. This is the heat that you get when you are dissolving something. Okay, so in this case, this is when this dissolved, it was endothermic. When you burn the Cheeto, it is exothermic. Okay. So next, let's talk about how we actually measure these. Okay, so what you did pretty much in your Cheeto lab is called calorimetry. Calories is a unit of energy, and meter is to measure. The way we measure that is we use a cup. This is called a coffee cup calorimeter. And pretty much you take the sample inside. The surroundings becomes the water, because that's what you're measuring. You have a stirrer right here just to make sure that the temperature is even throughout the whole water. So you put your sample in, and it'll dissolve, and then whatever the temperature change using a thermometer is the delta T. Okay. So calorimeter, the definition would be measuring. It's a device that measures calorie, which is a unit of energy. So measuring energy. There's another way to measure energy or heat, and that is called a bomb calorimeter. A bomb calorimeter is used for combustion analysis. As you remember, when you heat up the Cheeto had a lot of air. The reason is the heat is going everywhere else. Let's say this is the heat going here, and only a little bit of it is going into the water. It was it has a very big error, like about 95% error. So in reality, we use something called the bomb calorimeter. So imagine putting the Cheeto in here, in the little dish. Then you put an environment filled with oxygen so you can burn it. You attach it to like a little sparker right here, an electrical source. You spark it and it starts to burn. Then you can encase it with this metal piece that of course water can't get in there, because then if you get it wet, it won't be burning. You encase it in this metal piece, and then you dip the whole bomb. That's why it's called the bomb calorimeter, into the water. Here, the heat goes all into the water and nothing gets lost in the air. Then you take a little stir and you stir it, making sure that the water's temperature is even throughout. Then you take the rise in temperature here. That's called the bomb calorimeter, and is used for combustion analysis. An example of combustion is when you combust C3H8. You are mixing it with oxygen when you combust it, and you're making CO2 and H2O. Okay, so you can put any hydrocarbon in there. To balance this, go ahead and pause the video and balance it. Okay, so you put first you balance the carbons, 3, then you balance the H's, there's 8 there, so you need 4 right here. Then you balance the O's. Together here you have 6 O's plus 4 makes 10, so you put 5 right there. Okay, so if you want to combust this, you put, which is propane, you put it inside there and then you burn it and measure the heat. So now we're going to learn something called a molar heat of reaction. So this is the heat that you get for a chemical reaction, and it's for every 1 mole. So if you wanted to compare the heat for 2 different substances, it's better to compare the same amount. Okay, so this is called the delta H of reaction. The delta H stands for the heat, or Q, it's the same thing. Okay, so look at example number 1. The heat that you get, it says, if the energy from example 1 came from 3 moles of Cheetos, what is the heat of reaction in kilojoules per mole? Okay, so we're going to take the heat from a Cheeto, which is negative 11,088, negative 11,088 joules. I'm going to go ahead and convert that to kilojoules because it says kilojoules. 1,000 joules is 1 kilojoule is equal to negative. I'm going to go ahead and use 3 sig figs because here there's only 3 sig figs in the 50.0 grams, okay? So negative 11.1 kilojoules. Okay, that's however many kilojoules I got. And that is for 3 moles of Cheetos. So I'm going to divide that by 3 moles. Now, what does this mean? This is the amount of energy I get when I burn 3 moles for every 3 moles of Cheeto. So when I divide those, I'm going to get negative 3.70 kilojoules per mole. So now it's easier to compare with another molar heat of reaction because everything is for every 1 mole. Okay, so this is called the molar heat of the combustion of Cheeto. Okay, let's go ahead and pause the video and do this for the problem number 2. Okay, so example number 2 came from how much energy? Positive 3,012, okay, joules. So it came from 3,012 joules. Change that to kilojoules. 1,000 joules, 1 kilo is equal to, with 3 sig figs, I'm going to get 3.01 kilojoules. And it's positive, right? Yeah, it's endothermic. So then this is for, it says, molar heat of solution is the heat for every 1 mole, or the unit needs to be, heat is the unit for heat is joules or kilojoules. I'm going to use kilojoules because it's a big number for every mole. Okay, so I need kilojoules. Now I need moles. They gave me 80 grams, which is not in moles. Let's say 80 grams is what I was dissolving in here. Okay, it didn't say that, but that's what I was dissolving. So 80 grams, I have to convert it to moles. So 80.0 grams NaOH. 1 mole of NaOH is grams of NaOH. So I have to add up Na is equal to 22.99. O is equal to 16.00. H is 1.008. Add that up, I'm going to get 39.998. Commonplace value here. 40.00. Okay, I'm going to get 2 moles, 2.00 moles. Combining those together, delta H of a chemical reaction, I'm going to write it here because I have no room. Delta H is equal to 3.01 kilojoules for every 2.00 moles. Therefore, for every 1 mole, it is 1.51 kilojoules for every mole. So this is the molar heat of dissolving this solids of the solution.